Hello, everyone, and welcome to a talk on Open Policy Agent. My name is Amith Nambiar. I'm a platform architect at Pivotal, and my co-presenter today is also from Pivotal. Mark?
I'm Mark Puddick. I'm also from Pivotal. I'm also a platform architect.
Thank you. Open Policy Agent is a general purpose policy engine, and as part of our job, Mark and I get to speak to a lot of customers and prospects who are planning to adopt Kubernetes. So there is this one question that comes up always is how do we implement policies, custom policies on Kubernetes? Policies which they were used to implementing within their organization, probably for running their apps, other apps. How do we do that on Kubernetes? Right. Before I get into the crux of the talk, how many of you, a quick show of hands, how many of you have used Open Policy Agent before? Nice, a few people have used it. So the agenda for today is, it's an introduction to Open Policy Agent. Mark will be introducing Open Policy Agent. It's also called as OPA. And he'll be talking about the architecture of OPA and how does it fit in with Kubernetes, right? And after that, I will be talking about Rego, which is a policy language which is used to author your policies, and then do a demo on how it all works together. And hopefully the demo works. Over to you, Mark.
OK, thanks, Amit. So I'm going to talk a little bit about what OPA is. I'm going to talk a little bit about what policies are, and I'm going to talk a little bit about the architecture of OPA. There's a few different versions of it, so I'm going to sort of outline the difference between those versions. So I'll start with OPA. It's what it is. It's a unified policy toolset across the cloud-native stack, which is a bit of a mouthful. So we're going to kind of break that down a little bit into a little bit more easier to understand what it is. So it's a general-purpose policy engine. So what a policy engine kind of does, I guess, is it takes some information from, in a Kubernetes point of view, it takes it from a resource, and we'll pass that through a policy engine and can either mutate that resource or it can reject that resource. So if you think about the way that Kubernetes works, it's a declarative system. We have resources. They're all defined generally in YAML files. And then we have controllers that kind of watch those resources, and they keep your Kubernetes system running as your resources. So one of the things to update this, you go through, obviously, the Kubernetes API. And one of the things the Kubernetes API has is admission controllers. And I'll talk a little bit about that as we go through. And those admission controllers will allow you to basically mutate and validate your resource updates. And this is really where OPA fits in. It will come in and it will hook out from those webhooks effectively, and it will validate what you're doing. So you can use this to kind of enforce governance rules, and you can use it for things, for kind of all sorts of stuff. So if you think of anything that you define in a resource, you can kind of pretty much validate that. So things like which registries you pull from, network policies, that kind of stuff, anything that you would define. Container capabilities, so what kind of size of CPU, that kind of stuff you have in it. So that's all that kind of stuff you can easily validate, and you can mutate up to a point, and I'll talk a little bit about that as we go through. So the policies are defined in DSL called Rego, which I think Amit mentioned in his introduction. So he's going to talk a little bit more about that later in the talk. But it's effectively a DSL that processes effectively a resource, I guess, to check various things on it and provide whether you can, whether it's valid or not, I guess. You store the Rego in config maps, so pretty easy to set up. Just goes into etcd like anything else. Except in version 3, there's also custom resources around that as well, which I'll talk a little bit about as we go through the difference in the architectures between the various versions of OPA. So a couple of concrete examples of, say, a policy. It might be that we're coming up to holiday period at the moment, so it might be something like you might have a production blackout period. You could actually set up an OPA policy for that to say that no one can push into or no one can run deployments in production. You might have some GPU nodes in your cluster that you want to stop anyone using apart from, say, your data science team. So that would be kind of another type of thing. So this is kind of things you can do. And I think finally there you might have a check to see that all internet-facing services are using HTTPS. So I think the example that Amit's going to go through later in the talk is actually around restricting which container registries you can pull from, right?
Yep.
Yeah. OK, so I'm going to go through a kind of quick overview of what it is. We'll quickly go through the sort of architecture. We'll start at V1. Or actually, we'll talk about admission controllers first. So I mentioned admission controllers earlier. Just to give you a quick overview of what they are, from the Kubernetes documentation here, which I'll read it out for you, is an admission controller is a piece of code that intercepts requests to the Kubernetes API server prior to persistence of the object, but after the request is authenticated and authorized. So that's quite key. So as your request comes into the API server, it's going to get authenticated, it's going to get authorized, then it's going to go to what we call it's a mutating webhook. That's going to pass out to OPA. So you might have something on there like you have labels, for instance, that you need to have on required labels on your deployments. And you can make OPA could effectively mutate that and add that label for you. After it's gone through the mutating one, it then goes through the validation one, which effectively is going to return, it's a webhook that's going to return a yes or no response on whether or not that's valid. If it's invalid, obviously, it's not going to persist that resource and update your cluster. OK, so if we look at the different architectures, I've made these really simple, these diagrams, so that we can follow them easy. It's probably a little bit more complexity in reality. So if you think about, this is V1. So V1 is probably what most people are using today from an OPA point of view. There's actually two more versions, and I'll quickly go through those as well. But I'll quickly talk through the flow through this. So obviously, you've got your kubectl here, or you might have a control or pipeline, something that's using the API, Kubernetes API. That's going to send it to the API server. The API server is then going to go off to OPA effectively through the webhooks that we talked about a minute ago. And it's going to either mutate or potentially mutate and validate that resource, and I think Amit will demonstrate that when he comes to his demo. And the policy data, so that is effectively the Rego, that's stored effectively in this kube management sidecar here. So what that actually has in there, it's basically watching that policy data config, and we'll update it. So it's all cached in there, so if there's any kind of changes, it will update, but it doesn't go out every time you get an OPA request then to check, to reread that data. So it's trying to reduce the amount of network traffic they have. So that's kind of how it flows through in a kind of very high level. V2 has come along, I think a year or two ago. It's moved out some of the webhooks into this policy controller. That's added some extra things in there. So it's added audit and a few other bits and pieces in there. So it's also kind of made it, I guess, a little bit more Kubernetes-like, having it separated out. It's probably a slightly better model from that sense. And I think that came actually out of Microsoft. And then finally, we've got now, there is Gatekeeper, which is version 3. So this is an alpha at the moment. So I don't think there's anyone really using it in any anger, but there's a couple of key changes on this. They've kind of collapsed, the OPA team have kind of collapsed it into one thing on the actual OPA server, rather than having the 3 different things they had previously. They've also, the other key thing that they've done is they've added custom resources. So now when you do your Rego, you can have that templated. And because you templated it, you can get reuse of it. So if you've got something, for instance, like a label check, you can have a template for that in your Rego, and then you can have a custom resource to define what label it's checking. So that kind of stops you having to basically cut and paste your Rego through multiple versions and multiple different, slightly, similar use cases, but with maybe slightly different syntax that it's looking for. So that's kind of the 3 different versions of OPA. I'm going to just quickly talk, if you want to get it installed, It's very easy to get up and running. I'd recommend probably just using version 1 or 2. Gatekeeper's, say, kind of early days at the moment. It's going to be pretty easy to install, though. You just set up a namespace. Then you need to create a certificate for the internal SSL. And then you deploy the admission controllers for the webhooks effectively in the sidecars for that. And that's kind of pretty much done, right? So it's just effectively, at that point, it's almost not much more than just a standard Kubernetes deployment, really, with a few extra little bits. And then you're good to add your policies. It's very well documented. If you do want to go, there's a really good tutorial actually on openpolicyagent.org, which is where you can find all the stuff about OPA. And if you work through that, you'll get it up and running in no time. So I think with that, Amit's going to now go through, and he's going to give you a bit of a demo of Rego. Is that right?
Cool. Thanks, Mark. That was a good introduction to the evolving architecture of OPA. So OPA comes with policy language called Rego, which you can use to describe your policies. Order your policies. Right. So I'll walk through a policy written in Rego. What this policy is doing is it's restricting all image pulls from my registry. All images which are being referenced in your pod can come only from myregistry.io. So how many of you have deployed a pod on Kubernetes before? Yep. In the interest of those who have not deployed a pod is a very basic unit of deployment, and it can have one or more containers. And these containers have to reference an image from an image registry. So what this policy is doing here is it is going to restrict all image pulls from myregistry.io. To understand this policy written in Rego, it starts with a deny rule, which says that all these requests, the first validation is this a pod being deployed, right? To understand this better, you need to look at this admission review request, which comes from the Kubernetes API server to OPA, and OPA goes through this admission review request to validate the policy, whether this deployment or this resource can be created, updated, or deleted, right? So this is the admission review request. As Mark explained, this is architecture V1, and there is an admission controller webhook configured on Kubernetes API server for it to fire off that webhook to OPA, right? That's how the admission review request hits OPA. So this is an admission review request, and this is kind of self-explanatory. The deny rule is saying that if it first checks whether it's a pod being created. Imagine we are just after pods here. Then it checks. It basically builds an iterator over all the images here. As you can see, there are 2 images being referenced. There are 2 containers which are part of this pod. One's coming from myregistry.io. So in this imaginary example, that's our trusted registry, right? And the other one is from badregistry.io. So as we go through this, all the images, you get a list of images here. And as I said, it iterates over it and checks whether both the images are coming from our trusted registry. Since badregistry.io doesn't match it, it fails it, and the deployment doesn't go forward, right? So we will look at this example in action in a couple of minutes. So I want to introduce to you Rego, the playground, which is really handy if you want to try out your policies. So let's have a look. All right, as you can see, this is the same policy which I was showing before.
Make it a bit bigger.
It's a little bit blurred, isn't it? Yeah. So it's the same policy which I showed you before, and this is the admission review request here. And you can evaluate these policies, and as you can see here, the result is that the badregistry.io is not allowed to be pulled from this registry. So if I were to go in here and change it to my registry and run the evaluation again, you can see that it passes this check. So this is really handy because you can go and check, evaluate parts of this policy but it's just saying evaluate selection. As you can see, it's a pod, and it returns true. You can also see what gets actually created in this section here. You can see, as I said, you will get both the images, and an iterator is created, which will be iterated over in the next statement. So that's an example of this in action. This is a really handy tool, which I thought is really easy to understand the policy language better as well. Okay, I thought I'll show you another policy. This policy is not going to allow any containers which do not have the CPU limits defined to be deployed into a production namespace. Right, let's have a look at how this policy would look in Rego. Right. So this is the policy, and this is the resource limits. The first container, the Nginx container, has a CPU limit, and the second one, the Redis container, doesn't have a CPU limit. So if we were to evaluate this policy, it's very similar to the previous one, but it includes a check on the namespace, checks whether the namespace is production, gets all the containers, checks whether CPU has been defined for each of those containers. Right. So if I were to evaluate this one, okay, sorry, you can see the container Redis does not define CPU limits, hence this policy will be denied. I mean, the request would be denied, and the pod wouldn't be created. Right. Hopefully that gives you an understanding of how to write policies in Rego. Now, implementing a policy using OPA. OPA, the team behind OPA, the community behind OPA, has created this nice unit testing framework for you to actually test this policy, write a policy in a test-driven fashion, probably use it in a GitOps fashion as well, have a CI/CD pipeline, have these policies unit tested before you can actually deploy it into any environment. So I'll quickly show you what these look like. So this is, I'm sorry, I don't think everyone can see this. It's not very clear, but this is the policy which I was showing before. And you just try to test for this policy here. Maybe my Visual Studio might be better for this. Even this is not very clear, sorry. Anyway, the point is you can write unit tests against these policies. It's a little bit blurred. Is it better? Thanks. So as you can see, I've just have that mock request, the admission review request. I've stripped out all those fields which are not necessary for this test. All it's doing is calling this. OK, first I will show you how this test is run so that you understand what we are doing here. So the way to run this test is you need to first pass in your policy, which is written in Rego, and then you pass in the test case for that policy. So as you can see, you can run it in verbose mode and see that it has passed. Right? This is a really nice way of iterating over your policy and then finally, committing it into your repository, rather than trying to troubleshoot it in an environment. Right? So once this is done, I'll bring up the test case quickly. So all that it's doing is it's asserting here that the expected message that needs to come back from when the policy is evaluated is going to be bad registry.io sidecar for container sidecar does not come from a trusted, comes from an untrusted registry. Right? That's basically what the last statement is doing with input as unsafe image request. That's basically this mocked out request here. And it's very well documented as well on the OPA website. So once you have written your unit test for your policy, you can then deploy the policy as a config map to your Kubernetes cluster. So I have connected to a Kubernetes cluster here, and I'm just going to deploy that policy as a config map. Right? So I'm going to create a config map with the name image from trusted registry policy, and I'm referencing a file, which is the Rego which I showed you before. We just had our Christmas party yesterday night, so please don't be disappointed if the demo doesn't work and if I type something wrong. I can't remember anything now. So, it has created the policy. The next step is to check whether the policy has been deployed correctly. So what happens now is, as Mark mentioned, the config map has been created in the OPA namespace, and OPA is constantly watching for config maps being created in the namespace. It's going to get a callback, and then it's going to validate that policy. So the way you can figure out that your syntax was right and the policy was all good is you can describe that policy which has been just created. So all I'm going to do here is describe that config map which we just created. Yep. So you can see here, I didn't add an annotation on that config map. What OPA has, ingested this policy and put a status message of OK, saying that, OK, the policy syntax looks good, everything's all right with this policy, and it will start evaluating any resource updates against this policy. Right? So once that's done, the last test you want to do is actually deploy a resource and check whether the policy is being really evaluated. So in this case, what we are going to try out now is create a pod from bad registry, referencing an image from bad registry.io, and see that what happens when you try to do that. All right, to make sense of this, I'm showing you the policy as well. So a developer or your system trying to deploy this pod will get this message saying image not from your trusted registry, badregistry.io/nginx. So that's coming from here, right? The policy has been evaluated and the request has been denied. So as you can see, you can think of all your custom policies within your organization. You can try and think of how can you do this in Rego. This is just an example, but it's really handy. You can have really fine-grained control on what and how you can write your policies, right? All right. So I just want to summarize, okay, what did I actually do in this demo? So as a Kubernetes administrator, I will create a config map within a particular namespace. Now, Mark showed this architecture that's version 1, where we have kube management. Kube management picks up this config map and evaluates the policy and adds the annotation with the value policy status OK. Right? Kube management is basically watching for these. I think OPA makes that final decision, whether the syntax and everything, the OPA container makes that decision. Policy status of OK. Then the next, a developer comes in, tries to deploy a pod. Since we have a webhook configured on the API server, this admission review request is sent to OPA to evaluate the policy. Depending on the policies deployed, OPA either allows or denies this request. The admission review response is sent back to the API server, and the developer gets this sad message that the request has been denied, and it also gets a message saying that image from not from your trusted registry. All right, hope this puts everything in perspective and it's clear enough for everyone to see. Finally, I'd like to talk about getting context in policies. Right, sometimes just having an admission review request is not enough to make a decision to whether to allow or deny this request coming in. For example, imagine there is a request to create an ingress object, and you don't want two ingresses to have reference the same host field. So what is happening here is, till now, the examples which we saw, we're using just the admission review request to make a decision on whether to allow or deny. But what this is doing here is it's referencing the ingresses in all namespaces. Basically, it's getting data which has been created within Kubernetes to make that decision. It's iterating over all the ingresses which are available in the cluster and then comparing it with the incoming ingress create resource, and making a decision that, OK, if the host matches any previously created ingresses, then we are going to deny this request. right? So this is very well documented in that URL, Open Policy Agent. Please have a read. It's very well described. That's all we had today. Hope you found our session helpful, and thanks for coming.
Thanks, Sean.